Okay, let's start with parabola. We're gonna take it from parabola next.
Okay.
All right. So remember, when I say parabola, what am I referring to? A quadratic function, ne?
Yes.
And what is the standard form for a parabola? Do you know what is
A,
the standard form?
can I guess? Can I try?
Yes, yes,
A squared plus wait, A squared plus B X plus C.
exactly. So the standard form of a parabola equation, it's y is equals to ax squared plus bx plus c. So you see this formula, it's very important, and I'll definitely explain why you need to understand how this works. Né?
Okay.
Okay, so from this formula, uh, when your equation is given in this form, you need to know how to find what we call the turning point. You understand?
Yes, sir.
The turning point of the graph. So to find the turning point, uh, first thing first, you need to determine the x coordinate of the turning point. Okay. So the formula that you're going to use to find the x coordinate is equals to minus
Y.
b
Oh, okay.
over 2a. Okay, you wanted to say a different formula. Let me give you a chance. What formula do you use to find the turning point?
Is it not the one where you make y zero, y equals to zero?
No, that one is when you calculate the x-intercept.
Oh, okay.
You understand?
Yes, thank
Right.
you.
Okay, so now the x coordinate of the turning point, this is the formula that you need, and you need to do what? You need to know the value of b, you need to know the value of a. Everything will make sense when we do examples, okay?
Okay.
100%. So now, that's how you find the x coordinate. Then the y coordinate, this guy here, you're gonna find it by substituting. You see the value that you got, the x value. You're going to sub
Yeah.
the x value in the original equation. The x value into the original equation.
Equation.
You understand?
Yes, sir.
Okay. That's how you find the turning point if your parabola is given in that form. Let me
Okay.
move. So now the quadratic equation, it can either be given in a standard form or it can be given in what we call the turning point form. Do you know which one is the turning point form?
The turning point for I don't.
The
Wait, let
equation,
me
it will be given in this form. Y is equal to a into x minus p squared plus
plus
q. I think you definitely did this at school, eh?
yes, I did.
So for you to master quadratic equation, you need to understand uh, when the graph is given as the standard form and also when the graph is given as the turning point form. Okay,
Okay.
so when it's given in this way, it's going to be easy for you to find the turning point. So for this one, your turning point will be, you take the value of p is to the value of q. So this will be your x and this will be your y value for the turning point. Are you happy with that?
Yes, sir.
Okay. So let's say that, listen, let's say that uh, you have your x-intercept. I'm still on turning point. Let's say
Okay.
that you have your x-intercept unknown. You know what are your x-intercept. So let's say they give you the graph where you know your x-intercepts. So if you know your x-intercept, the equation that you need to use to find the equation of your graph will be a into x minus the first x-intercept, and then on the other side you minus the
The
second
second one.
x-intercept. Are you happy with that?
Yes.
Okay, so this is when you know the x-intercept. That's the formula that you're going to use to find the equation of the graph. Listen, you said your name is Amu.
My name is Amahle.
Amazi. Amazi,
Yes.
listen, eh? You
Okay.
see now, when you need the turning point, so if it is given in that form and you are looking for the turning point, since you know your x-intercept, to find the x coordinate, okay? So in order for you to find the x coordinate, this is how you're going to find the x coordinate. You're going to take those two x values, you add them. The answer that you get, you divide by 2. You understand?
So this only works when I have the x-intercepts when they're known.
Exactly. When you have the x-intercept, that's how you find the turning point.
Okay.
Then to find the y, you know what you need to do. You take the x that you got, you
And then you
sub
substitute it.
in to the original equation. Okay. Are you with me on that?
Yes, sir.
Okay. So now, let's move now. Wait, do you have any question based on this information? We have three
No.
types. Né? It's either they
Yes.
give you the question in standard form, you know how to find the turning point. It's either they give you in turning point form, you know how to find the turning point, or let's say they give it to you where you know your x intersects. Then you
Okay.
know how to find the turning point. 100%. So now, let's talk about the domain and range before we start with examples. Né?
Okay. The domain refers to the x values, ne, and then the range is the y values, ne?
Exactly. So let's
Okay.
look at this example. And let's say that I have a graph like this. The graph is concave up, and the graph looks like this. Okay, so let's say you have this type of graph. Né?
Okay.
Right. So on this graph, you know what I'm going to do. Let's say that I have the turning point here, and the coordinates of the turning point, let's say it's -1 and 2. Okay, so since it is in this quadrant, even the 2 will be negative. So -1 and -2. Remember, the x value of the turning point is what we call the line of axis of symmetry. The line of symmetry. The line of symmetry, it divides the graph into two equal parts. So this line
Okay.
will be x, it's equals to -1. Are you still with me on that?
Yes, I am.
Okay, let's first determine the range. What will be the range of this graph?
The range is y is that thing, you know that thing with like looks like a big E and
An
then
element.
open bracket. Sorry?
An element.
Yes, so it's y, an element, then open brackets. Is it like -2 until infinity?
-2 until infinity. I must say, thank you very much. That is very, very correct. Né?
Okay, thank you.
So look at this. Né? You know, most of the time when you want to determine you said Amasi, né?
Yes.
When you want to determine the range, this is you'll be flying from the y-axis. Né?
Yes.
So you fly along the y-axis. So the moment you start moving up, you ask yourself, where do you see the y values of that graph. So if you look at this question like this, you can see that from this blue line going down, you don't see any y values on the graph. But from this blue line going up, from -2 going up, you start seeing the y values. You start seeing the y values. You understand?
Yes, I understand.
So the range means that the range is y must be greater or equals to -2. That's your range, which is the same answer that you gave me in that interval notation.
Okay.
Understand?
Yes, I do.
Okay. So let me give you a tip. Né? Listen, if the value of A is greater than 0, your graph is concave up, right?
Yes.
Therefore, your range will be y must be greater, which is the sign that you see there, and then you put the equal sign. It must be greater than that coordinate, y coordinate of what? Of the
It,
turning point of your TP. The range is y must be greater than the y coordinate of TP. You understand?
yes, I understand.
If the value of A is less than 0, the graph is concave down. Then look at this. Your range, its y must be less than, you use
Less
this
than.
sign here, less than or equals to the y coordinate of what? The coordinate of your turning
Telling.
point. Are you happy with that?
Yes, I am.
Right. Now let's dive into the domain. What will be the domain of this graph?
X is an element of mm, there also -1 until infinity.
Nope. Remember, the domain will look at the x values. Né?
Yes.
Which x values does this graph take? It takes all the positive and all the
And
negative value. It's always like that. Né? X is an
yes,
element of real numbers. It will always be x is an element of real numbers. The domain of the function of the parabola
a real
does
number.
not change. You understand?
Understand?
Last thing is that you need to understand what we call the equation. Okay, so the last thing that we're going to discuss is what we call the equation of the symmetry axis. So remember, the symmetry is the line that divides the graph into two equal parts, and that line we said is -1. It's x is equal to -1. So now do you understand how the parabola works? Should we dive into examples?
Yes, please.
Okay, so what I'm going to teach you now, let's say that you are given a standard form. Remember, the standard form, if we say that the parabola is in standard form, this is the standard form. So let's say you need to move from standard form to turning point form. Let me write this down. So you need to move from standard form and you want to convert that to the turning point
Point.
form. So tell me, how can we do that? Look at
Then
this. Let's say you are given the equation y is equals to 2x squared and then minus 4x then plus 10. Okay, so
is there
how
a
can
need
we
for a
move?
calculator? Can we just like replace P and Q? Like they used to use to show our working, or can you just replace into P and Q?
How are you going to replace P and the P and Q?
Okay, because P that doesn't P like represent X, or we don't know what X is.
Okay, let me explain this now. Maybe after explaining this, you'll have maybe I'll be like you definitely gonna have your answer. Eh?
Okay.
So to move from standard form to turning point form, I need you to do this by completing the square. Do you know how to complete the square?
Yes, it's algebra, no?
Exactly. So you need to complete the square, and I'll definitely remind you how we complete the square. Né?
Okay.
First thing first, when you complete the square, make sure that this x squared it's on its own. So what I'm going to advise you is to take out the 2 as a common factor. That's number one. Because 2, I need the x squared to have the coefficient of 1. So I'm going to take the x squared out as a common factor. Then I'm left with 2x plus 5. Are you happy with that?
Yes, I am.
Then you see now, whatever that you have inside the bracket, you're going to complete the square. So when you complete the square, you're going to add, uh, what is this? You're going to add b over 2a. Wait, it's b over 2, ne?
Yes, it's
Not
negative
2.
B over 2.
It's b over 2. Then, oh, it should be b over 2
A.
then squared. You understand?
Okay.
On both sides. But let's take this step by step. So this will be 2 into x squared. You see? Then you're going to minus that 2x. After the coefficient of b, after the coefficient of b, after this term, that's when you add that guy.
The, okay.
Okay, you add it, then you subtract. You add it, you definitely subtract. You
Subtract.
add and subtract both. This is maths. You can't just say 2 plus 4. Then this is the given equation. You are given 6. So for us to always have 6, I can add 3 and subtract 3. So I did not change anything because these two cancel.
Yes.
You understand that?
Yes, I do.
Okay. All right. So now you add and subtract. So after adding and subtracting, this is what you're going to do. You're going to say x squared minus 2. You add, please, I need you to be very careful. I'll explain what you need to do. What is the value of b? Let me ask you, what is the value of b?
Negative 2.
Exactly. It's not 2, it's negative 2. So this will be, we add the value of b, which is minus 2 over 2, then everything squared. Whatever that you are adding, you should subtract it. So that's minus 2 over 2, then squared. We still have plus
Can
5,
I,
right?
can I ask a question?
Yes.
You adding B over 2. When you add B over 2 squared, not negative B over 2 squared.
We add negative 2 over b squared.
Okay. So here, like at our formula, when we add the things, there's no negative.
Which one?
Where we said we add B over
This
2 squared
this
and
part.
subtract. Yes, there's no negative there, right?
Yes, there's no negative.
Okay, thank you.
Sure. There's no negative. So
Okay.
now another most important thing, look at this. You see this term. After that being x, after bx, the term that comes after bx. Oh, am I saying it?
Yeah, well,
Listen, you only work the brackets only. You understand me?
okay. Yes.
Okay. Let me show you what I mean when I say the bracket only. So this will be y is equal to 2 into x squared minus 2x plus, you only work the bracket. Minus 2 divided by 2, that's minus 1. You leave it as with the to the power 2. You leave it like that, I'll explain why. But this one, you can definitely punch this whole thing on your calculator, tell me what you get. You should get positive 4. Because we know that minus 1 squared, that's positive 1. Then which will be minus 1, then plus 4, that's plus 5, that's 4. Is that equal to 4?
Um, yes, it is.
Listen, the first one, you only work the bracket. The next
Okay.
one, you add it with the constant value. Then, now let me explain. The reason the first one I want you to add it with the bracket is because I had to work only what's inside the bracket. Can you see these two terms? Both of
Yes.
them are to the power 2, right?
Yes.
And we can consider them as the difference of squares. So we can put them in the same bracket and say this is 2 inside the bracket. So we can definitely put this as what? X, then minus 1, then everything squared. Do you understand that part?
Yes, I understand that part.
Then we still have plus 4. So when you are done, you need to multiply everything by the 2. You take the 2, you multiply this whole term by that 2, which will give you y is equal to 2 inside the bracket, x minus 1 squared. Then you take the 2, you multiply the 4, which will give us plus 8. Therefore, this is in the form of y is equal to 2 into x minus 1 squared plus 8.
Yes.
So what will be the turning point? Remember, the turning point it's x is to p. Oh, I'm sorry. P is to q. I'm not sure if you understand how this works.
I think I understand.
All good.
Yes.
Okay, so now we're going to say that it is in the form a into x minus p plus q. Okay, and we set the TP. It will be x, oh, p
It
and
will be
q.
PQ.
So what will be the turning point of this equation? What is your TP?
-1 8.
It's not negative 1. Remember,
Oh,
the reason we got P is because we take the x minus P, we equate it to 0. Therefore, the x is P. So it will be
okay.
positive P. You take the x minus 1, you equate it to 0, which gives us 1 and 8. So that's your turning point.
Oh, okay. Thank you.
Is this making sense?
Yes, it is.
Because we're about to move to the next important part of this lesson. Ne?
Okay.
All right. So we talked about the range, we talked about the domain. The next important part in hyperbola, in parabola function. You see now I'm still teaching you some of the things that you need to know. Then we'll definitely work on the past paper on the upcoming lesson. Okay?
Okay.
Okay. So listen. Now, in an exam, they'll ask you this type of question. For which values of x, it's f at x greater or equal to 0, or they'll ask you where it's f at x less than or equal to 0. I know that most of the learners, they hate this type of question. Hopefully, after this explanation, you'll be able to answer this on your own. Yeah?
Okay.
Right. Okay, so now let's say that you have the graph that looks like this. Okay, so on this graph, I'm just gonna write it down the values there. Let's say this is -4. Please come in.
Bye bye.
This is 1. Should we continue?
Yes, we can. Sorry.
Okay. So now look at this now. First thing first, number one. Let's answer for which values of x it's f at x greater or equal to 0. Listen,
Okay.
when they say, remember, this is the same as y greater or equal to 0. This is simply meaning where is the graph
Above.
above the x-axis, above the ground. Right? So
Okay.
this line here is your ground. So where they're asking you, where is the y above
X. The x-axis, ne?
the ground? Where do we have the positive y values? So from this point, going all up, we have positive y values. You understand? So
Yes.
all these values on that graph, they will have positive y values. You understand?
Yes.
So you're going to indicate on the graph, where is this graph above the ground? So this part here, it's where f at x is greater or equal to 0. And then below, it's where f at x is less
Is
than or
less.
equal to 0. I'm going to indicate from this point, going up, that graph is what? It's going to be
Greater than.
exactly. And then from this point, going down, your graph is less than.
Yes.
Are you happy with that?
Yes, I agree with you.
So when they ask you for which values of x, uh, when they say for which values of x is f at x above the ground, it's from this point going in that direction, and from this point
Going
going
in
in that direction. Therefore, the answer is x must be less than 1 and greater than minus
negative
4.
4.
Are you happy with that?
Yes, I am.
Okay. And then this answer can be written in this form. X must be an element of, since they are included, it start from minus 4 all the way to 1. Remember, included means greater or equal to net.
Yeah, but
So if this one is for greater or equals to, for greater than, it should be like this, minus 4, small brackets, meaning that minus 4 and 1 are not included in the solution.
okay.
100%. So tell me, what will be the answer for f at x less than or equals to 0?
It can in x is greater than negative 4 and in x is less than negative 1.
No, 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 no. Try again.
Okay, wait. X is equals to. Okay, can it be x is equals to negative 4 and then or x is equals to 1?
You know, I can see that you know what is the answer. You're just struggling to say your answer. Eh? Where is f at x below the ground?
It's by that point, the blue lines.
Look at this. The blue lines, which is from this point going that side. You understand? And
Yes.
from this point going in that direction. So the answer for this one is x must be less than or equal to minus 4 and x must be greater or equal to 1.
Oh, okay.
And how are we going to write this in that notation? It will be x must be an element of, we start from negative infinity all the way to minus 4. But the minus 4 is included. Infinity, we don't know the number. There's no way we can include that infinity. Union, and then or, we say it start from 1 all the way to positive infinity. Are you happy with that?
Yes, I am.
All good.
Yes.
Okay. Okay. Do we have enough time?
We have about 25 minutes.
Okay. I guess we can go through an example, okay?
Okay.
Okay, so on this example, let's say we are given a parabola when we have the turning point. Ne?
Okay.
So let's say you are given the parabola like this, and from this parabola it is in this form. And then let's say we have the turning point form, minus 1 and 8. The coordinates here, it's minus 1 and
And
minus 8. Ne?
yeah.
And then this is your point A, this is your point B. This is your point A, and this is your point B. Okay?
Okay.
Let's say this is F. First thing first, let me give you one other point. So this point here, minus 2 and minus 6. So let's say this point is negative 2 and negative 6. So let's answer the following questions. Ne? The first question, number 1. Let's find the equation of the graph. Find equation of f at x. Okay, so now when they want us to find the equation of f at x, remember, if we have the turning point, so we can use the turning point form. You still remember what is the turning point form?
Is
If I go back up, this was the turning point form. So
A,
we
yeah.
exactly. So I'm
Yes.
going to use that part to work this thing. So this will be y is equals to a into
X
x minus p
P
squared
squared
plus
P plus
thank you.
P.
Now remember your turning point, its p is to q, and the turning point is given as what? Minus 1 is to minus 8. You understand?
Yes.
So when you do your substitution on that equation, we're going to say y it's a into x minus p it's negative. I'll put it inside the bracket. Then everything squared. Then I'm going to add q, which is negative 8. So this will be negative 8. If I simplify this gives me a into x plus 1 squared minus 8. What's next? What should we do to find a?
Looking, and then I think we can find X to find A.
We can
We
find
can
x.
yes.
Remember, you have other point, which is this point has the x coordinate and the y coordinate.
Can we use the X formula, the one that was like X minus X1, or you don't have the second X?
Look at this. If we substitute that one I don't think can work. But if we
Okay.
substitute this on this equation, do you agree with me that the only unknown variable this time will be a? Then we solve for a.
Yes. We can say -6 is Y, and then -2 is X.
Exactly. So we're going to sub in the values minus 2 and minus 6. So this is your x, this is your y. On the equation, where there's y, you put minus 6, and then where there's x, you put minus 2.
Okay.
Then you can start solving. So when we solve this thing, we're going to say this is minus 6, it's equals to a into minus 1 plus 1. Minus 1 plus 1, that's 1. 1 squared, that's 1. So this will be 1 minus 8. So the minus 8 comes this side to be positive. Then I'm left with 8 times 1, which is just 8. Therefore, when you add the 2, you'll find that The value of A is just positive 2 because minus
2.
6 plus 8, that's 2. The value of A is 2. So this is your value of A. So if this is your value of A, the equation of the graph will be y, A into x minus p squared plus q. Now we know the A is 2. X, we have this as plus 1.
1.
This is squared, then minus 8. So this is the equation of the graph. Are you happy with that?
Yes, I am.
Okay. Listen, if you want, you can definitely put the equation in the standard form. If you want, you can just simplify this equation. You understand?
Okay.
I'm just teaching you how to play around this thing. So remember, we just
If you
calculated.
simplify it, how would it look like?
I just want to show you that part. So this is
Okay.
2 into x plus 1 squared, right? Minus 8. So when I simplify this is 2 into, I expanded the bracket, x plus 1, and then x plus 1, then minus 8. Remember, the 2 multiplies everything on that 2 bracket. So y is equal to 2 into x squared plus, this will give us plus 2x if we add the like terms, then plus 1, close the bracket, minus 8, multiply out the bracket by that 2. So this is 2x squared plus 4x plus 2 minus 8. The final answer is 2x squared plus 4x, then minus 6. So this is standard form because it's in the form of ax squared plus bx plus c. Do you get that part?
Yes, I understand.
Okay. So tell me, what is the equation of the axis of symmetry for this graph?
Um, -1.
Find the equation of axis of symmetry. Okay. The equation of axis of symmetry, you know what I'm going to do? You go to your turning point form, you take whatever that you have inside the bracket, whatever that you have inside the bracket, you're going
Okay.
to, whatever that you have inside the bracket, you equate that to 0 and solve for x. That's your equation of symmetry. You're going to take the x plus 1, equate it to 0, your x will be minus 1. So the answer for this one, x is minus 1. The
-1.
equation of symmetry, x is equal to minus 1. Are you happy with that?
Yes, I am.
Okay. Okay. So the next question, let's say they want you to find the range. I think that one will be an easy one. Can we find the range? Are you still with me?
Yes, I am. I'm making it out.
Oh, okay. The range, number 4, find the domain. Okay, what will be the range? You just have to look at the graph. What will be the range of this graph?
Okay. Um, but like we're not only given one x value.
Remember the range. Which y values can this graph take? Remember what I said.
We can take
Uh,
-1 until infinity.
remember what I said. I said that if a is greater than 0, your range will be y greater than the y coordinate. If
Yes.
a less than 0, your range will be y less than the y coordinate. Look at this graph. This graph is concave up. What will be the range?
The range will be it's greater or equals to -8.
Exactly. So y is greater or equal to minus 8. The range is y is greater or equal to minus 8. Okay? Or you can definitely say it takes from y, it's an element of included minus 8 all the way to positive infinity. That's your range. The domain, I said that the domain, it's always x must be an element of real numbers. That does not change, okay?
Okay.
Next question, they want us to find the coordinates of A and B. Find the coordinate of A and B. What is the coordinate of A and B? This is your A, this is your B. What are the coordinates of A and B?
Let me check real quick.
No,
What did
I
we
don't
say?
say work it out, but what do we call these coordinates?
We call them our x value.
The x-intercept. That's where the graph cuts the x-axis. Remember, this is your x, this is your y, right?
Yes.
This is where the graph cuts the x-intercept. So now, look at this. I don't want to waste time, ne? Already, we know that if this equation is given in this form, we can write it in that form. You still remember? Y is
Yes.
2x plus 4x minus 6. You understand?
Yes.
So 2x squared plus 4 minus 6. So I'm just going to move that. But you need to first, you start from this point, you move all until you get to that point. So already I've showed you how to put it in standard form. I'm just going to start from that point. So I'm going to say y is equal to 2x squared, then plus 4x, then minus 6. So we say these are the x-intercept if y is 0. So where there's y, we'll put 0 and solve for x. Okay, so to solve for x, I need to work with a simpler equation. Let me divide everything by 2 because I prefer working with the x, the coefficient of x squared being 1. So this gives me x squared plus 2x minus 3. It's 0. Then I can definitely factorize this. When I factorize this, this is x, and then the factors of 3 is just 3 and 1. Then the sign of the middle number, you give it the bigger term, the bigger number, and then this one will be negative. Therefore, x is minus 3, or the value of x is 1. The coordinate we set if y is 0. So this will be minus 3 and 0. Then this will be 1 and 0. You need to conclude which one is A, which one is B. A is in between quadrant 2 and 3. So the x values are negative. All these x values this side are negative, and B will have a positive x value. So the one that is positive, that's your B. And the one that is negative, that's your A. Is that making sense?
Yes, it is.
Do you get this? Do you understand how this works?
Yes. Can
Okay.
I ask a question, ma'am?
I'm listening.
Here when you said the factors of 3 and 1, when we were still solving, like the way I was taught, ne, the factors of 3 and 1, there must be they should be equals to 2. Like you must add and plus them to be 2.
Exactly.
Okay.
Exactly. Going to say the factors of 3 is just 3 and 1. When you add these factors, you need to get 2. The only way to get 2 is when 1 is negative, this one is positive. So when you add the 2, you get 2, which is your middle term. Do you understand that?
Yes, I do.
100%. Okay, so the last two questions, for which values of x, it's f at x greater or equal to 0, and for which values of x is f at x less than or equal to 0. Let's try and answer this question.
Okay.
because I just want to use the last 5 minutes to talk about increasing and decreasing function. So tell me, for which values of x it's f at x greater than or equal to 0? So we know that this is minus 3. We know that this is 1. So for which values of x, it's f at, remember we said above the
Anyone.
ground, it's where f at x is greater or equal to 0. Below the ground, it's where f at x is less than or equal to 0. So
Yes.
what is the answer for the first one? Number 1, where it's f at x greater or equal to 0.
So when it's greater, it must be so it's negative, it's less or equals to -3. It's greater than greater equals -3, and then also great or less than -1.
No, no, no,
Greater.
no. Say that again. Remember, it's when it's greater than it's from this point going back up. Can you see that? So
Yeah.
meaning is from this point in that direction. So x must be greater than what? Greater
Then
or equals to 1, or from this point, look at this, going in that direction. So from this point going in that direction, or x must be less than or equal to -3. Do you understand that?
yes.
Okay. So I know that you know the answer, but you're just struggling to uh,
To
say
say
the greater or less than. So from this point, going that side, we can see that the graph is below the x-axis, and from this point going that side. So x for the second one, where it's f at x less than or equal to 0, it's when x is less than or equal to 1, or when x is greater or equal to -3. So it's just the opposite of that answer.
okay.
Oh, we don't have, okay, it's fine. Let me explain increasing and decreasing function, then we can call it a night.
Okay.
Okay, so the last part of this lesson, it has to do with when they say decreasing or increasing function. Okay,
Okay.
so you'll see that when you write exam, there will be question like where, for which values of x is f at x an increasing function. Okay, so let's say that you have a graph like this. Okay, and then let's say that you have another one that is concave down. Listen, for a graph to be increasing, wherever you go up the slope, you are increasing. Just know that the concavity changes at the x value of what? Of your turning point. So I'll assume that this x here is 1, and then let's assume that this x here is -5. So the x value of the turning point this side is -5. For that one, let's say it's 1. So this is you, ne? You will walk from left to right, ne?
Yes.
Can you see that the moment you start getting to this point, you'll start decreasing? Can you see that? You're going
Yes.
down until that point. So this tells you that from this point, going in that direction, the graph is decreasing.
Decreasing.
You understand? So when they say
Yes.
where is the graph decreasing,
When
x
it's
must be
less
less
than
than
1.
1. And then from the moment you start going up the slope, you are increasing.
Increasing.
Meaning it's from this point going in that direction, the graph is increasing. Wherever you go up the slope, you are increasing, means that you have a positive gradient. So x must be greater, it's increasing when x is greater than 1. Same applies this side. This is you move from left to right. The moment you start going up, you are increasing. So you are increasing from this point, going in that direction. You are increasing when
X
x
is
less than
less
minus
or
5.
equals 5.
Then the moment you start going down, you are
You're
decreasing.
decreasing.
So this side is decreasing. Is decreasing if x is greater than minus 5. Are you happy with that?
Yes, I am.
Thank you very much. And that's it from me. This is where we're going to stop for today. Please have a great evening. If you don't have any questions, uh, this is where I would like us to stop for today. I'll definitely work with you until you write your June exam. Okay.
Okay, thank you.
Okay. Thank you. Sharp, sharp. Thanks.